Hey guys, in this video we're going to talk about Chapter 1, Section 3, Functions and Equations. So the first thing we need to do is remind ourselves what expressions are, and now we're going to introduce something called equations. And so sometimes students get confused between the two, so I want to make sure that you guys understand the distinction. Okay, so first of all, for expressions, you are not solving for a variable. There is no equal sign in an expression, and typically you'll get the directions saying evaluate or simplify. So sometimes, you'll have an expression and they'll say, evaluate the expression for x equals 2. And so you just have to plug in 2 into that expression and do the math to get an answer. It consists of variables, numbers, and operators, as we mentioned in the previous video, and we have some examples here. Our first expression is 3x squared plus 2x minus 1. Notice that this consists of some terms, things stuck together with multiplication, variables, numbers, operators, addition and subtraction, but there's no equal sign. So that's the big difference between an expression and an equation. Here's another expression, different variables, but nevertheless still an expression. And then down here we have a pretty simple expression. There's no need for any variables in the expression as long as we have at least one number that would qualify as an expression. But the big thing here is that expressions do not have equal signs, and therefore we're not solving expressions. We can evaluate expressions, we can simplify expressions, but we cannot solve expressions. So, on the other hand, looking at equations, we are solving for a variable. We're going to go, much more in depth into this in a few more slides, but basically we're trying to see what the missing variable is, like what number we need to replace with the letter in our equation. With equations, we are moving terms across the equal sign, and in the directions for when you solve equations, you're going to see the word solve. You're not going to see evaluate, you're not going to see simplify, solve, right? Just like expressions, equations consist of variables, numbers, and operators, but the big thing here is that equations have equal signs, and that's what we're going to be focusing on today. So, our first example, this is an equation, 3x plus 2 equals 9. On the left side of the equal sign, we have an expression, 3x plus 2. On the right side of the equal sign, we have an expression, 9. Here's another example of an equation, slightly more complicated than the first one. And here we have another example. So this is just, again, two expressions being equal to each other is an equation. We could have a really simple equation. We could have something like 2 plus 2 equals 4. That would qualify as an equation because we have an expression 2 plus 2 on the left side of the equal sign, and on the right side we have an expression 4. So, all pretty good examples of equations. So, equations can be true or false. So, true equations are mathematical truths, basically. So our first example here, 3 plus 1 equals 4, that's a truth, right? And, if we simplify this, we get 4 equals 4. That's a mathematical truth. Same thing here, 8 times 2 equals 16. That's a truth. 9 equals 9. That's another truth. We could also have false equations. For example, 9 minus 3 is not equal to 10. So this equation is false. 6 does not equal 1. That's a false equation. And 4 divided by 2 is certainly not equal to 28. So equations can be true or false. So what we're going to be doing for the rest of this video is we're going to be searching for solutions to equations. So a solution is a value that we can substitute in for the variable that makes an equation true. For example, x equals 2 is a solution to the equation 5x plus 3 equals 13. Because, why is that? Well, because if we sub in our value 2, if we sub in our solution in for x, we get the following. We get 5 times 2 plus 3 equals 13. And then on the left side of the equal sign, we can simplify this. 5 times 2 is 10 plus 3, and we end up getting 10 plus 3 equals 13. Simplifying even more on the left, we get 13 equals 13. So this is true. So 2 is indeed a solution to the equation 5x plus 3 equals 13, because when I substitute it in for x, I get a true mathematical statement. So let's do an example. Another example of this is x equals 1 a solution to this equation? Well, all we're going to do is we're going to sub in 1 anywhere we see an x and see if we get a mathematical truth. So let's go ahead and do that. So anywhere I see an x, I'm putting a 1 and leaving everything else as it is. So working on the left side first, using order of operations, 1 minus 2 is negative 1, so I get 8 times negative 1 on the left side. And on the right side, 8 times 1 is 8 minus 2. Simplifying the left side again, 8 times negative 1 is negative 8. And on the right side, 8 minus 2 is 6. Now, is this a true statement or is this a false statement? Well, this is false. Negative 8 doesn't equal 6. The only thing that equals 6 is 6 itself. So, or the only number that equals 6 is 6 itself. So, this is not a solution. No, x equals 1 is not a solution. If it was, we would get a true statement at the end of this simplifying, but we don't. We get a false statement. So let's do another one. Which of the following are solutions for the equation 2x squared plus 4x equals x squared minus 3? And we want to go ahead and check all 4 of these. So starting with x equals 0, again, wherever I see an x, I'm plugging in 0 into this equation. So I'm going to just do that. I'm just going to leave these parentheses open and plug in my zeros at the end. So I see those 3 spots are where that's where x was in the equation. So we're going to plug in 0 into those spots. And then we can simplify the left and the right side. So using the order of operations, I do exponents first. 0 squared is 0. So 2 times 0 plus 4 times 0 equals 0 squared on the right is 0 minus 3. So on the left, I just get 0 plus 0, right? Which is 0. So 0 on the left equals negative 3 on the right. That is not a true statement, which means that x equals 0 is not a solution. Now let's go on to the next one, which is x equals negative 1. So I'm just going to go back to this, and instead of 0, I'm replacing all of my x's with negative 1. Anywhere I see an x in my original equation, I'm subbing with a negative 1 to check if it's a solution. Okay, so again, order of operations, looking on the left side of the equal sign, and maybe I can actually draw a line through it to make it a little easier to see. Negative 1 squared is negative 1 times negative 1, right? And negative times a negative is a positive, so that's positive 1. So I get 2 times positive 1. And then 4 times negative 1 is negative 4. Again, on the right side, negative 1 squared is positive 1. And if I simplify this out on the left, I get 2 minus 4 equals 1 minus 3. And so 2 minus 4 is negative 2. 1 minus 3 is also negative 2. This is a true statement, which means that x equals negative 1 is a solution. Let's try x equals 1. So same process, I'm just subbing in 1 in here. Okay. All right, so looking at the left side, I get 2 times 1 squared is 2 times 1 plus 4 times 1 is 4 equals 1 squared again is 1 minus 3. On the left side, if I simplify 2 plus 4, that's 6 equals 1 minus 3 is negative 2. That is not a true statement. So x equals 1 is not a solution. And finally, let's do x equals negative 3. Okay. So again, order of operations on the left side, we want to do negative 3 squared. Negative 3 times negative 3 is positive 9. So I get 2 times positive 9. And then positive 4 times negative 3 is a negative 12. Again, on the right side, I get positive 9 minus 3. On the left side, 18 minus 12 is 6. On the right side, 9 minus 3 is 6. That is true. So x equals negative 3 is a solution, as well as x equals negative 1, but x equals 0 and 1 are not solutions. So the whole goal of this section is to find solutions to equations. Sometimes it's really obvious. Like if you have a super simple equation, it's obvious what the solution is, what the missing number should be to make the equation true. So for example, if we look at number 1, what this is asking is what number plus 2 is 5? That's what this says in words. When we are looking for variables, we're looking for the missing number that makes the statement true. So what number plus 2 is equal to 5? Well, that has to be 3. And that is kind of obvious from looking at this. So we just found a solution to this equation. The next one says, what number, y, minus 10 equals 20. So I take away 10 from a number and I get 20. What number is that? Well, that has to be 30, right? So y equals 30 is our solution. So we call this, sometimes you'll see this in the textbook, solving by inspection, because we're literally just looking at it and trying to figure out the missing number to make it true. Okay. Next example, 3 times z. So if we don't have any symbol between two things, it means multiplication. So this is 3 times z. 3 times z equals 6. So 3 times what number z is equal to 6? That has to be 2. So z is equal to 2. Okay. Variable a. So what number divided by 2 is 40? So another way to think about that is I take half of a number and I get 40. What number is that? Well, that has to be 80. So those are our solutions to each equation there. So what if the solution isn't obvious? Like what if you're given something crazy like this and you're asked, well, what's the solution? Well, it's not immediately clear what it is because it's so complicated looking, right? I mean, all of these equations are pretty simple and we could kind of figure out what the variable was by inspection. But if the solution isn't obvious, we need a strategy to solve these equations. And I'm going to show you how to solve equations just like this. And maybe we'll come back to this one at the end of the video and see if we can solve it. Okay, so the big idea, when you have an equation, it's a balanced scale. So, or a seesaw, if you want to think of a seesaw, right? So let's say we have the equation x plus 2 equals 5. Well, what this is saying is that the left and the right side are completely balanced. They're the same weight. You can think about it like that. So you have two friends, maybe x plus 2 is one friend and 5 is the other friend, and they weigh the exact same amount, and so they're completely balanced. The seesaw is completely flat. Now, what happens if I put a rather large person on the left side of the seesaw? Well, what's going to happen is x plus 2 is going down right? That's how this works. If I were to put a fat person on just the left side of the seesaw would go down and the equation would no longer be balanced. You see? So that is something, we can't do something to one side without doing it to the other. That is a big idea here, right? So what happens if I put another person on this side that's the same exact weight? Well, it stays balanced, right? So that's the key idea here. Whatever I do to one side of the seesaw, aka the left side of the equation, I better do to the right. And you can do anything. I mean, I could put fat people on here. I could multiply both sides by 5. I could square root both sides. I could take the cubed root of both sides. I mean, the possibilities are endless. I just have to do the same thing to both sides to keep it balanced. Okay, so that's the big idea here. This is the most important thing you'll probably learn in this class. The golden rule for solving equations. Just like I said, whatever you do to one side of the equal sign, you better do the other. And so equation we can think of as equal sign if we want to think of it like that. So let's talk about strategies for solving equations. We need to isolate the variable. We need to get the variable by itself. And to do that, we can perform what's known as inverse operations on the side with the variable. So what are inverse operations? They're basically opposite operations. So like addition and subtraction are opposites. Multiplication and division are opposites. Squaring and square rooting are opposites. Cube rooting and cubing are opposites. You get the idea. So that's what we're going to use to get these variables by themselves. Let's do some examples. So, and we're going to start with some simple examples. Again, for these simple examples, you can really inspect them and see what the answer is, but we're going to use inverse operations to do this. So let's look at our first example. We have x plus 2 equals 5. Now, what I tell my students every time I teach this is to draw a line through the equal sign so that the left side and the right side are distinct. Again, you can think of this line as being the balance point on your scale. You can think of this as the seesaw. And so whatever I do to the left side, I need to do to the right. Now, what you do is you want to get x by itself on the left, and so you need to do the inverse operation that's happening to x. What is happening to x is addition by 2. What is the opposite of addition by 2? That's subtraction by 2. So I'm going to go ahead and take 2 away from both sides. I better do it to both sides, right? Now, x plus 2 minus 2. The reason I did the minus 2 was so those would go to 0, right? Positive 2 and a minus 2 go to 0, and I'm just left with x plus 0, which I don't have to write. I can just write x. X is equal to 5 minus 2, which is 3. Okay, so my answer here is 3, and we can see that by inspection and plugging that in to get a true equation. So here, x is equal to 3. Okay, let's do some more examples. So the next one we have is y minus 3 equals 8. I'm going to draw my line through the equal sign, and I'm working on the side with the variable. I want to do the opposite of subtraction by 3 to clear it out to 0. Right? Because I want y by itself. That's the objective. So what's the opposite of subtraction by 3? Well, it's addition by 3. And I can't just do it to the left side because then it won't be balanced, right? The seesaw is going to go whoop down, right? So I got to do it to the right side as well. And you can write it horizontally or vertically. It doesn't matter. Okay, so negative 3 plus 3 goes to 0, right? I can just clear that out, y plus 0. So what I get is y equals 8 plus 3, which is 11. So that's my answer here. Y equals 11. Okay. 2x equals 4. 2 times what equals 4? Well, we know what that is. But let's do it the right way. Well, not the right way, but, whatever. So we work on the side with the variable, and we see what's happening to the variable. What's happening is multiplication by 2. how do I undo multiplication by 2? What's the opposite of multiplication by 2? That's division by 2. So I got to do the same thing to both sides. Now, what's 2 divided by 2? That's 1, right? So on the left side, I get 1x. Okay? On the right side, 4 divided by 2 is 2. Now, I don't have to write the 1 in front of the x. It's simply 1x is the same thing as x. So x is equal to 2 is my solution here. Okay, let's look at the next one. Z divided by 8. So a number z divided by 8 is equal to 10. What's the magic number? I'm going to draw my line through the equal sign. And what's happening on the side with the variable is division by 8. So how do I undo division by 8? I need to do the opposite of dividing by 8, which is multiplying by 8, right? On both sides, because I want to keep it balanced. So 8z over 8 is just 1z, right? So these 8s just cancel out, right? They divide each other out to 1z. And I'm left with 1z equals 10 times 8, which is 80. So that is our answer here. You can always check your answer by plugging in the solution you got into the original equation and seeing if you get a true answer or a true mathematical statement. For this one, if we do 80 divided by 8 on the left side, we do get 10. So 10 equals 10 is true, so we know that we did that one right. All right, let's look at number 5. We have negative 5 plus x equals 10. Draw this line through. Now, what I like to do with equations is I always like the variable to come first. It just makes it look easier. Now, addition is commutative, and what that means is that you can switch the order around. So negative 5 plus x is the same thing as x minus 5. Exact same thing. I didn't do anything to one side and didn't do something to the other. I simply reversed the order because they mean the same exact thing, right? Because for x, we still have a positive secretly in front of it that's not being written. This guy has a positive here. The 5 has a negative in front of it in both cases. So these are the exact same thing. And so this looks easier to work with, right? Now, we didn't do something, I want to stress this. We did not do something to the left side without doing it to the right. We simply changed the order around. We didn't add anything in additional. Okay, so here, working on the side with the variable, we want to undo subtraction by 5. What's the opposite of subtraction by 5? Adding 5. So I need to add 5 to both sides. Here I get 0, and I get x on the left side plus 0, which I don't have to write. 10 plus 5 on the right is 15. So that's my answer here. Okay, so those were pretty straightforward. Now what I want to do is talk about multi-step equations and some strategies that you can use to solve them. So you always want to combine like terms if you can before you do any moving across the equal sign. You want to also group your variable, like your like terms on one side and your constants on the other. And then the third strategy is when you're moving terms across the equal sign, we want to start with the numbers that are farther away from the variable. And hopefully when we do some examples, I'm going to point out what that means. And hopefully you'll see that. So let's look at this first example. We have 3x plus 7. Now I'm going to draw my line through the equal sign to know that the left and the right-hand side are separate. Right now we have an even seesaw on the left and the right. I want to get x by itself. So what I'm going to do is I'm going to start working on the side with my x. I want to clean it up, get rid of that other stuff. And I'm going to employ number 3 because I don't have like terms that I can combine right now. I want to get x by itself. That's the big idea. And so I want to get rid of the number that's farthest away from the variable. So what's happening farthest away is addition by 7, right? We have two things that are happening. We have multiplication by 3 and addition by 7. And addition by 7 is further away from x than multiplication by 3. So I'm going to get rid of the addition by 7 first. So how do I do that? Well, I got to do the same thing to both sides. And the opposite of addition by 7 is subtraction by 7. So I'm going to do that to both sides. That clears on the left, and I'm left with 3 times x on the left. On the right, 40 minus 7 is going to be 33. So my seesaw is still balanced. I have 3x on the left side and 33 on the right because I took 7 pounds away from both sides. Now what do I need to do is I need to get x by itself. So again, I look to the left. That's where x is. What is happening to x that I can get rid of? What's happening is multiplication by 3. How do I get rid of multiplication by 3? I need to do the exact opposite, which is division by 3. I need to divide both sides by 3. And when I do that on the left, I get 1x, or just x. And on the right, 33 divided by 3 is 11. Now, what you can do when you're doing your homework, again, is you can see, like, if you're not sure if this is right, you can go back and plug it into the original equation. So our original equation was 3x plus 7 equals 40. And I'm not sure if my solution is right, of 11. So to check if it's right, anywhere I see an x, I'll put an 11 in. So I have 3 times 11 plus 7 equals 40. And indeed, on the left side, I get 33 plus 7 equals 40. Yes, 40 does equal 40, so I know that my answer is correct. So that's how you can check yourself. And I highly recommend that you do that with your homework. Okay, so here we go. Let's do it. So solve for the variable and check your solution. I'm not going to check the solution for all of the problems that we do, but just to show you how to do this. So I'm going to work on the side with the variable, draw a line through the equal sign, and I'm going to do undo the operation that's furthest away from the variable, which is subtraction by 4. So how do I undo minus 4? I have to add 4 to both sides. And on the left side, I get negative 2 times x equals 16 plus 4 is 20. Now, am I going to add 2 to both sides? Well, certainly not. I'm not subtracting 2 from x. I'm multiplying negative 2 by x. Do you see that? Because there's no symbol in between the 2 and the x. That's multiplication. So I want to do the opposite of multiplication by negative 2, which is division by negative 2. So on the left side, that clears out to 1, and I'm just left with 1x on the left side equals 20 divided by negative 2 is negative 10. And so we can check our answer. We can check our answer by looking at our original equation and subbing in negative 10 in for x. So I get negative 2 times negative 10 minus 4. Does that equal 16? PEMDAS, negative 2 times negative 10 is 20. Minus 4 equals 16. Well, that's true. So that is our solution, x equals negative 10. Okay, looking at number 2. So drawing the line through the equal sign, the operation, I have 2 operations happening on the left side with the y. I have division by 3 and I have addition by 2. So which one is further from the variable? Addition by 2 is further. So I'm going to go ahead and subtract 2 from both sides to undo the addition by 2. Rewriting, I get y divided by 3 equals 10 minus 2 is 8. And what I need to do with this next step, look to the side of the variable and say, how do I get rid of division by 3? I need to do the opposite of division by 3, which is multiplication by 3 on both sides. So that clears to 1. So I'm just left with y is equal to 8 times 3, which is 24. So that's my solution. You guys should check this. I'm not going to check this one, but you should check it to make sure it works out. Number 3, we have z plus 4 all divided by 3 equals 2. Line through the equal sign. I'm looking to the left because that's where my variable z is. And I have two operations. I have addition by 4 and I have division by 3. Which operation is quote unquote farther away from z? Well, the division by 3 this time is further away, right? Because the plus 4 is right there next to the z. So what I need to do is first get rid of the division by 3 by multiplying both sides by 3. Now, you're not going to distribute the 3 up here, okay? Because when you have the 3 multiplied by all of this, let me write it all out. I just want you guys to really see what this is, what's happening here, okay? So just bear with me here. When we have this, we can simply divide out the 3's to 1. And when that happens, we no longer have to distribute this thing in there. That wouldn't make any sense. So that just clears, is what I'm trying to say. So on the left side, we just get z plus 4. And on the right side, 2 times 3 is 6. Finally, looking to the left where my variable is, I want to undo addition by 4 by subtracting 4 from both sides. And I get z equals 2. And that's my solution. Go ahead and check yourself to make sure that that is indeed the correct solution. Okay, in your homework, you're going to see stuff like this. It's just different wording for solving equations. So it says solve f of x equals 0 for x. All it's saying is like plug in 0 for f of x. They're literally telling us this. F of x is 0. Plug it in. So instead of f of x, I'm putting 0 equals 8x minus 3. Now, this time my variable is on the right side, so that's where I'm working. We have multiplication by 8 and subtraction by 3. What's furthest away is subtraction by 3. So I'm going to start by adding 3 to both sides. Now, why don't I add 3 to the 8x? Why isn't that not 11x? Well, it's not like terms, right? I'm just adding 3 to the negative 3. All right. So on the right side, that negative 3 and 3 clear to just give me 8x on the right. And on the left side, I have 3. Now, looking at the right side, that's where my variable is. I want to undo multiplication by 8. So to undo that, I need to do the opposite of multiplication by 8, which is division by 8. That's the inverse operation. So when I do that, I get x on the right all by itself, 1x equals 3 over 8. And I can't simplify that anymore. Okay, let's do some more examples. We're just trying to solve for the variable here. I encourage you to pause the video, try these out for yourself. So looking to the left side, again, I like the variable first. It just makes me feel more comfortable. I don't know about you guys, but I like to use the commutative property to first rewrite and then move the things across the equal sign. So on the left side, you see the 20 is positive because there's an implied plus sign in front of the 20. You see the 3 is negative because there's a negative in front of the 3. So why not rearrange it to look like this? That's the same exact thing as above. All right? Same exact thing. So that looks better, doesn't it? So now I'm going to undo the operation that's furthest away from x, which is addition by 20. What's the opposite of adding 20? Well, that's subtracting 20. So I'm going to subtract 20 from both sides. And I get negative 15 on the left side. I still have negative 3x on the right side. Am I going to add 3 to both sides? Don't you dare do it. We're going to divide by negative 3 because this is multiplication. This is not addition. This is not subtraction. This is multiplication. There's no operator between the 3 and the x. That's multiplication. So I am going to not add 3 to both sides. No. I'm going to divide both sides by negative 3. All right. So that goes to 1. Excellent. I get x by itself. On the left, x is equal to negative 15 divided by negative 3 is a positive 5, you guys. Again, go ahead and check yourself. Make sure that that's correct. Okay. Looking at number 2, let's draw a line through the equal sign. Now, number 2, I can make it look a little bit better. I mean, there's a couple different ways you can do this, but I always try to get rid of the parentheses first, right? Because it's easier to work with an equation without parentheses. And to do that, I have to use the distributive property. So I'm just going to rewrite this using the distributive property. On the left side, 4 times x is 4x. And then 4 times negative 1 is negative 4, okay? Now, did I add any weight to the seesaw on the left side? Did I do anything weird that I would have to do the right side? Well, no. I simply changed the form. 4x minus 4 is the same thing as 4 times x minus 1. I did not shift the weight here, so I don't have to do anything to the right side. Okay. On the left side, I have 4x minus 4. The first thing I'm going to do is get rid of subtraction of 4 by adding 4 to both sides. And I get 4x is equal to 8 plus 4, which is 12. Looking at the left side again, I want to undo multiplication of 4 by dividing both sides by 4. And I get my solution of x equals 12 divided by 4 is 3. Okay. Let's look at number 3. So number 3, we want to use tip number 2 in the multi-step. Let's see, where was it? This one right here. Group your variables on one side. So like we have variables on both sides of the equal sign, and we want to move our variables to one side, basically. So I'm going to look at the right side, and I'm going to say, how do I move this over to that side? Well, I need to get rid of it, I have to subtract both sides by 3x, right? Now 3x minus 3x is 0, so let's rewrite this. On the right side, I'm left with 6. On the left side, the like terms that I have 9x minus 3x, and that's going to give me 6x, and then the minus 1 is still there, all right? So I just moved the variables to one side. Now what I want to do is look to the left side, because that's where my variable is, and I want to first undo subtraction of 1 by adding 1 to both sides. So on the left I get 6 times x, on the right I get 7. Now what I want to do is divide both sides by 6 to get x alone. And I get x is equal to 7 over 6. That's my solution. Okay, let's do some more examples. Solve for the variable. We have 6 equals the square root of x plus 1 minus 3. So the operation, we have some operations here. We have square rooting, we have adding 1, we have subtracting 3 on the right side. So the operation that I want to get rid of first is the subtraction by 3, because it's the furthest one from the variable. So to do that, I can add 3 to both sides. Keep in mind that I'm not going to add anything under the radical, because you can't combine a number under the radical with a number that's not under a radical. So 6 and 3 on the left make 9, and then I'm just left with the square root of x plus 1. Right, the negative 3 and the 3 cancels over there. So now I have 2 operations left to deal with. On the right side, I have the square root, and I have addition by 1. What operation is further from the variable, or on the outer layer, is the square root. So I need to get rid of that first. I can't just subtract 1 from both sides. That's highly illegal. So I want to undo that layer of square rooting. Now, what's the opposite of square rooting? Is squaring. So what I want to do is I want to square both sides. Just like addition and subtraction cancel each other out, squaring and square rooting cancel each other out. So on the left side, when I squared 9, I get 81. On the right side, when I square the square root, it simply disappears, right? Cancels out. They're inverse operations. So I'm left with 81 equals x plus 1. And looking to the right, because that's where my variable is, I'm going to go ahead and undo addition of 1 by subtracting 1 from both sides. and I get my solution. I get x is equal to 80. Okay, let's look at this next one. Maybe I'll erase some of this to just clean it up a little bit. Okay. All right. So my variables on the right side, I have some operations that's happening. I have multiplication by 4, I have a square, and I have subtraction by 64. So what's the furthest operation away from the variable is subtraction by 64. So I'm going to go ahead and add 64 to both sides first to undo that. When I do that, I get 64 is equal to 4x squared. Okay. Now I have multiplication by 4 to get rid of. So how do I undo multiplication by 4, right? This multiplication here. I have to divide both sides by 4. So that clears out when I divide by 4. 64 divided by 4 is 16, so I get 16 equals x squared. And finally, I need to undo the square by square rooting both sides. Now keep in mind, when I actually physically take the square root of something, I have to tack on a plus or minus. So on the left side, the square and the square root cancel to just give me x. And on the left side, the square root of 16 is 4, but I need to tack on a plus or minus. So there are actually two answers that are going to make the original equation true. The first answer is -4. If I plug -4 in for x, I get a true statement. And the second answer is +4. If I plug in +4 for x, I also get a true statement. So we have actually two answers for this one. Let's move on. So number 3, let h of x equal -2 plus x minus 1 all over 3. Solve h of x equals 8. So again, this is kind of like the one we did before. It's telling us literally sub in 8 for h of x. That's what it's telling us. It says h of x is 8. Put it in here and solve it. So let's do it. So h of x is 8. So we have 8 equals -2 plus x minus 1 all over 3. Now again, it's up to you, but I like to rearrange first. Now on the right side, I can rearrange this by writing the term with the variable first, and then the -2 can come after that. Okay, do you see how this and this are the same exact thing, right? Okay, so this equals 8. Now, on the right side, what do I want to get rid of first is the operation that's farthest away from the variable, which is subtraction by 2. So I'm going to go ahead and add 2 to both sides. Again, horizontal, vertically, I don't care. 8 plus 2 is going to give us 10 equals x minus 1 all over 3. And the operation furthest away from x, we have two operations on the right side. We have subtraction by 1, and we have division by 3. The outermost operation that's farthest away from x is division by 3. So we need to do the opposite of that, which is multiplication by 3 to both sides. So that clears. And on the left side, I'm simply left with x minus 1. And on the left side, I'm left with 3 times 10 is 30. All right, on the right side where my variable is, I'm still dealing with subtraction of 1. So I need to get rid of it by adding 1 to both sides. And so I end up getting my final answer, x is equal to 31. Okay, let's do another example. So solve for t, this time our variable is t, just like x. So I can clean up the left side. And when I clean it up, I'm not adding anything to the seesaw. I'm just cleaning it up, okay, to make it look a little bit more familiar so we can work with it. Now, the first thing I like to do is get rid of the parentheses by using the distributive property. So let's go ahead and do that first. -2 times t minus 4. Well, -2 times t is -2t. -2 times -4 is a positive 8. And then everything else carries down, which in this case is plus 6t. Okay. Now, on the left side, I have like terms. I have a -2t and a positive 6t. -2 plus 6 is a positive 4. So this is positive 4t plus 8 and equals 27. So again, just to make this clear, I didn't add anything to the left side. I just made the form look different. I just cleaned it up a little bit. So I don't have to do anything to the right side quite yet. But now I'm in a good position because this looks familiar. So 4t plus 8, I want to first get rid of addition of 8 by subtracting 8 from both sides. So on the left side, I get 4t, and on the right side, I get 27 minus 8, which is 19. On the left side, I still have multiplication of 4 by my variable, so I'm going to do the opposite of that, which is division by 4. So I'm going to divide both sides by 4, and I get t is equal to 19 over 4, which cannot be simplified. Okay, let's do another one, drawing my line. So the left side I can clean up. I see two places where I can use the distributive property. The first place is right here, so I'm going to do that first. And then I'll carry everything else down. So 2 times 6 is 12, and 2 times negative 8k is negative 16k. And then I'll just carry this other one down. Okay. Now my second distributive property is right here, right? I'm multiplying not just the 3, I'm multiplying the negative 3, because that's the sign attached in the front. I'm multiplying the negative 3 by negative 2 and by positive k. So carrying the stuff in the front down, now we have negative 3 times negative 2 is going to give me a positive 6. Negative 3 times a positive k is going to give me a negative 3k. And then I still have equals 20 on the right side. Okay, now on the left I can combine like terms. I have these guys to combine, and I have these guys to combine. So 12 and 6 make 18. And negative 16 and negative 3 make negative 19. So there's my combining like terms. And from here, what I can do on the left side, if I want the variable in the front, I can just switch the order by the commutative property of addition. And now I can solve for k. So I'm going to first undo addition of 18 by subtracting 18 on both sides. And I get negative 19 times k is equal to 2. Finally, I want to undo multiplication by negative 19 by dividing both sides by negative 19. So, weird answer, but it's okay. I get my variable k is equal to 2 over negative 19, and that's my answer. Let's do one more. Okay, drawing my line through the equal sign. I'm going to work on the right side first because it's the most complicated, and I see parentheses that I can distribute. Use the distributive property. So that's what I'm going to do first. I'm going to distribute the 2 in there, and 2 times 8x is 16x, and 2 times negative 7 is negative 14. And I still have this negative 3x at the back. And on the left side, I have 3x minus 4. Okay. So on the right side, I notice that I can combine like terms. So before I move anything, I want to make sure that terms are combined on their respective sides. So on the right side, 16 minus 3x is going to be 13x. So I just combine those guys on the right side. And now what I want to do is I want to make sure all my variables are on one side. So to do that, since I have a positive 3x on the left side, I can undo that addition of 3x by subtracting 3x from both sides. So on the left side, I have negative 4. On the right side, I get 10x, 13 minus 3 minus 14. And now what I can do is look to the right and say, well, what should I do to get that x alone first? I can undo subtraction of 14 by adding 14 to both sides. So on the left side I get 10, and on the right side I get 10x. And finally I can just divide both sides by 10 to get x alone. And 10 divided by 10 is 1. So x is equal to 1. That is my solution.